Section 4, Video 1. In this section, we're talking about the special properties of kites and trapezoids. In the previous section, we looked at the properties of parallelograms, rectangles, rhombi, and squares. So this is a bit of a review from our quadrilateral chart. We had a preview to some of these properties, but we're going to be a little more overt and look exactly at what the special properties of these different quadrilaterals are. So for a kite, remember what defines a kite is that it has two consecutive sides that are equal. So if I were to draw your run-of-the-mill kite, it's to say that these two sides that are consecutive, or one right after another, are equal, and then these other two sides are equal. And we have four properties from that. One is that the diagonals are perpendicular. That's to say that if we had a diagonal from this side to this side, and a diagonal from this side to this side, that is a right angle, so they are perpendicular. The second property is that one pair opposite angles are equal. So that would be this angle and that angle. And we can think about it as, if we think about that blue line that's going right down the middle, that makes two congruent triangles out of that kite, because we can use our side rule to show that those two triangles, this one on the left and this one on the right, are congruent, which would mean that those angles would be congruent. We can also know that the vertex angles, the ones at the top and the bottom, are bisected. So that's to say that this is the same angle as this, and the same up here, that this is the same measure as that. And so that is what we mean by vertex angles. And the opposite angles are these ones right here. So once again, it's really, for me, it's all about going back to this triangle right here, and how that triangle is congruent with this one on the right. And how we know that those, because of CP/CTC, we know that those corresponding angles are going to be equal. And the last property we have is that one of the diagonals is bisected. And we know it's going to be this one here and here, because think about, we could extend this kite all the way way down there to make it that blue line way longer on the bottom than it is on the top, so it wouldn't be bisected. So we know that horizontal line in between the opposite angles that are equal are the ones that are going to be bisected, so we have half and half on each side. So if we were going to look at an application of this and how we can use what we know about kites to find some different angle measures, we'll look at this kite, K-I-T-E. And this is going to take lots of labeling and looking at the picture, and that will pretty much give us all our answers. So I'm initially going to start just by filling in as much as I can. So if I recall the properties, I'm going to blow this up a little bit so I can draw some more on it. So I know that this is 80 degrees, and since I know, because of those congruent triangles, I know it bisects the angle, so that this angle is the same measure, so this also has to be 80 degrees. And same for down here, this also has to be 28 on this side. I know that this is a right angle, and all of these are 90, so that would make us able to find those other angle measurements in all of the other triangles on those right and left sides there, because we know two of the other angle measures. I know that this whole KT is 8.2. So this whole thing is 8.2, and since I know that those are equal, the diagonal is bisected, that this has to be 4.1 and this also has to be 4.1. So if I start to look at what I need to figure out, I'm looking for angle KIC, which I've already found is 80 degrees, up there at the top. Angle KIT is the sum of 80 and 80, so that's going to be 160 degrees. CET is down there on the bottom right, and I've already filled that one in as well, as to be 28 degrees. KET is once again a sum, so 28 plus 28 is 56. KCI, since I know that those diagonals form a perpendicular, that it has to be 90 degrees. The length of CT, so half of KT, has to be 4.1. I already know what KT is. I know it's 8.2. That's a given. And let's see, I think there's one more. Okay, so this one's a little trickier. It's if KI is 12, so KI is right here. So I know that that is 12. What is IC? So it's asking me about this line right here. Well, I'm going to sketch that over here. Take it out of the kite. So I know that this is 12. I know this is a right angle. I know this is 4.1. And I'm looking for this IC. So this is what I want to know. I'll just call it X. So when I draw it like that, I can see that because it's a right angle, I can use the Pythagorean theorem to know that one side squared plus the other side squared equals the hypotenuse squared. And from there, I just solve for x. So I have x squared plus 16.81 equals 144. X squared equals, and then if you subtract those, or 16.81 from 144, you get 127.19. And then if you do the square root of both sides, you get x equals 11.28. So therefore, IC equals 11.28.